Now we're going to work with hyperbolas, our last conic section. So let's take a look at the formulas here first. And as you look at these, they should look very similar to especially the ellipse formula. So let's just talk about what these are first of all. When we did the ellipse, we had an x squared plus a y squared. So we had a curve plus a curve to form this ellipse. So that was x squared plus y squared. When we worked with a circle, again, we had an x squared plus a y squared to form the circle. The difference with circle is that we had the same radius. Now we have these hyperbolas. So hyperbolas have a minus sign in it. So take a look there. We've got a subtraction sign between our x squared and y squared. So hyperbola is going to be an x squared minus a y squared. So these curves are going to be going away from each other. We've got x squared minus y squared. Just to point out our parabolas, we don't want to leave that poor guy out. A parabola only had one x squared or y squared, so that's why we only had one curve. Alright, let's take a look at this slide here. I have a couple diagrams, one with a horizontal hyperbola. Up here I have the formula for a horizontal hyperbola. Now, it's horizontal because it opens left and right. Notice on the formula that the x squared is first. The x values go left and right, so that's why this hyperbola opens left and right. The vertical hyperbola on the right side here, you'll notice opens up and down. Again, remember the y-axis goes up and down. Look at the formula. Our y is first, y squared minus x squared. Alright, so that's what our two pictures are going to look like, our graphs. The center on both of my diagrams here is at 0, 0, but just like it was for the ellipses and the circles, the center is always just found by hk. Remember, the h is always the opposite of the number you see with x, and k is always the opposite of the number you see with y. Be careful, especially with the vertical, because the x is second, so that you don't mix up your center. Alright, hyperbolas are just a set of all points p such that the difference of the distances between them and two fixed points called the foci is a constant. Alright, so the constant is c, just like it was before. Notice where, look down at the diagrams again here, the focus, I'm putting little x's over where the foci are. They are inside the curves. So the focus should always be inside the curve. Now, in order to find the focus, we need c, and if you look at the formulas only have a squared and b squared in it. So I'll talk about that in just a minute. In order to find c, we are going to use a squared plus b squared is equal to c squared. Now, be careful, because with the ellipses, you did a squared minus b squared. So this is a squared plus b squared. We'll be using that in just a minute here. Alright, let's talk about a. Notice a squared is always the first one that you see. A is not necessarily bigger than b like it was for ellipses. So the a value is under the x, and that's going to tell you how far away from the center the vertex is. So, vertex is just the distance a from the center to the point on the, now here's going to be a new word for you guys, it's called the transverse axis. The transverse axis, we don't have a major minor here, but the transverse axis is just the axis that connects the two vertices. So the transverse axis goes left and right because x goes left and right for a horizontal hyperbola, and it's under the x. Now, the transverse axis for the vertical hyperbola goes up and down. The a is under the y, y's go up and down. So you'll see that a is just the distance from the center to a vertex. B is the distance from the center in the opposite direction. And we'll talk about this because you see a rectangle forming the rectangle right here is what's going to help us find our, my favorite word in the world, asymptotes. Now, asymptotes are the lines that are going to help us draw the end behavior of the hyperbola. So here's these asymptotes. Notice the asymptotes go from one corner of the rectangle through the center to another corner of the rectangle. And we will actually look at some examples that deal with this.